So next we're going to look at using the solver in Matlab to solve systems of differential equations. This is using the solver to solve systems of differential equations. And so let's first of all take a look at this differential equation here. We're asked to solve this differential equation. We have dx dt, dy dt, dz dt with the initial condition x at 0 is 20, y at 0 is 1, z at 0 is 0.5. And we want to solve this system of differential equations over this time interval, t equals 0 to 0.5 hours. So we're assuming that t then is measured in hours. And so we're going to go through this. Now notice a couple of things. We have one independent variable, t, and three dependent variables, x, y, and z. So be sure, that's one thing to note from the beginning. One independent variable. And three dependent variables. Which are x, y, and z. And so we're going to reassign these. And again, you can pick any variable name you want. I would suggest picking something different. So we have an x, y, and z and a t. I'll pick w. So I'm going to reassign these dependent variables to a vector that starts with w. So let's take a look at that. Reassign the dependent variables. And so what we'll do, like I said, the new variable we use will be w. So x becomes w1, y becomes w2, z becomes w3. Again, I just use w, but use whatever. Now, of course, keep in mind, Matlab is case sensitive. So if in this case I'm using a small w, so we have to be consistent. You can use a large one if you want, but you have to be consistent throughout your program. So we reassign these here. Then we're going to also reassign the derivatives in like manner. So here we had x became w1. So dx dt will become dw1. So let's do that. So dx dt, again, this is going to become dw1 like this. Dy dt becomes dw2, and dz dt becomes dw3. So I did x was w1, then dx dt was dw1, y was w2, dy dt was w2, and z was w3, dz dt was dw3, like that. And next, we're going to write the MATLAB code for our function. Now, the function is actually going to go at the end of our code, but let's write it first to kind of get an idea of how to do this. Now, our function will include the system of differential equations. So let me write it this way. So function. And let me say dw. And I'm going to call this equation 1. Again, remember it's case sensitive. So whatever lower or uppercase letters you use, you have to be consistent. If you use equation with a small e here, you have to use a small e when you call the equation. So I'm going to call it equation 1, but this can be your own name, whatever name you want here. This can be whatever name you wish. And we'll have our independent variable t and our dependent variable w, like this. And then for the dw, and we're going to have to set this equal to zeros to start with. I'm not going to give a lot of detail, just kind of write it down so that you can see how to do this on your own if you want to use the solver. Now, this 3 here is based on the number of dependent variables. So let me just note this here. And remember, Matlab, you can use a % sign for a comment. It won't try to execute something after a % sign. So again, this will be 3 dependent variables. And so this will be like a column matrix. So this will be the 3 here, and then just always keep this at 1. If you had 5 dependent variables, this would be 5, 1. And then write your differential equations. So let's write what we have. So let me just pull these up to give you an example of one. So this the first one, let's look at this one. Let's write this in our Matlab code. So it's going to be dx dt, but remember x is going to be w1, so dx dt will be dw1, like this for this. Then over here, remember x was w1, so it's going to be minus 3 times w1. And then plus 4 times y, remember y w2. And then plus e to the minus t. Remember, in MATLAB, exp is e. And the the independent variable doesn't change, so it's going to be minus t, like this. And then times sine 2 times t. Hopefully you can see that. So that's writing this first equation. Dx dt becomes dw1, minus 3x is w1, y is w2, then e to the minus t exp minus t times sine 2 star t for 2 times t. And let's do the next one. The next one is going to be dy dt. Remember, y is w2. So dy dt is going to be dw2. And then times 5x. And of course, 5 is w1. Plus 9 times z. And z is w3, remember? Plus 4 exp to the minus t star cos 2 star t, like that. And I'm going to do the third equation as well. I'm kind of running out of room to show everything on the screen. But the third equation is this one right here. So dz dt will be dw3 equal to w2 for y plus 6 star w3 minus exp to the minus t, like that. And then finally, the last thing you have to do is just put an end for the end of your function. Like that. Oh, by the way, did you notice I forgot my star over here? This should be 4 star exp. We have to always in Matlab have to put this, of course, a star between anything that we're multiplying. So it should be 4 star exp. And so that's our function. This is the function that we're going to call from our Matlab code. Like I said, it's actually going to go at the end of our code, but I wanted to write it now just to kind of get that out of the way. And now let's write the first part of the code. Now, a lot of times I'll put a clear all at the top. I won't do that here when I'm writing this down, but sometimes you might want to do it if you've been running the same code over and over again and you're changing things. You might want to reset everything, but MATLAB sometimes suggests that you don't do that, so I won't do that here. Now, first of all, so when we're at the early part, we need like our time span. I'm just going to call it T-span. You could actually give this whatever name you want by just putting something down here to get you started. And remember, we're supposed to go from t equals 0 to 0.5 hours. So let's make that 0 and then have a space and 0.5. And again, these are square brackets. Be sure you notice those are square brackets here. Again, this is going to be, I'm going to put a comment here, time interval. And then we want the initial conditions. I'll just call this, you can call these whatever, and I'll call this W init. And again, give it your own name, maybe something more large. Remember, the initial conditions were X was at 20, Y was at 1, and Z was at 0.5. And so put those numbers in, once again, a square bracket, 20, 1, and the other initial condition was 0.5. And I'm going to just put a comment here again, initial conditions. And now we're going to call our function. So we're going to call that function we created, and we're going to solve it. So again, use square brackets. Notice everything on this stuff so far has been square brackets. T is our dependent variable, W. And then I'm going to use the solver called ODE 45. And it's written this way with no space. There should be no space there. Let me just make it clear that that's no space. Again, you can choose another solver. I'm just choosing this one because it's one I've used in the past. And I'm just giving you something, get you started working. And then over here, put at and put whatever your function name was. And I called our function equation 1. You have to write it exactly like that. Equation. You have to, whatever name you gave it, and you give it any name, but it has to be exactly written the same way. And the cases have to be the same. And put a comma and put your time span. Remember, I called it T-span. And put your initial condition. Like this. And I'm going to put the semicolons to suppress the output. And so we have it like that. Now, notice you could have written this time span right in here. You could have put this with the square brackets in here, and you could have put the winnet. You could put this with square brackets right in here rather than assigning these extra variables. But it seems to me be a little bit clearer if you assign these variables first to see what you're actually doing. And so now this is really what calls and solves your differential equation. Now we just want to plot it. Once again, I'm just giving you the most bare bones way of getting started, and you can experiment all you want. Again, we're almost done getting a plot here. So we'll plot, and what this is, it'll plot. This is going to plot first dependent variable. Use a semicolon, that will give you the whole row, and then put a hold on. And I like to have a grid. You don't have to just put a grid on, but you're going to need to hold on because when it draws the other curve, it will automatically erase this unless you put the hold on. So let me draw the other, plot the other ones. And I'm sorry, this is number 2. And this is number 3. There's actually no space here. Let me pull that in just a little bit so it's clear. There's no space. And we're actually done. Now we just have to type this into Matlab. And again, this is what solves the ODE, this ODE 45. And this plots it. So let's go ahead and put it into Matlab. And so next you want to go into Matlab and be sure on the top here, you're under, best thing to do is be under editor tab. If you look across the top, push editor, then go over here to new, and you can do new script. Under new, do script and hit that, and then just start typing everything in. And then just start typing your code. And I'll just type in a few lines and show you the final code. I don't want to sit here and have you sit there while I'm just typing things in. So let me just type. Remember, for like the T-span and for the initial condition, you have to use square brackets. And then I'll show you again. You probably want to put the semicolon to suppress the output. Remember, if you don't want too many things printing, do the semicolon. So I typed in the main body of the code. Then I typed in the function there below. I'll show you this on printed paper. It'll make it a lot easier to see. But you can see I typed everything just as we had. As I mentioned, you want to put the function near the end of your code here. And the earlier part of the code up here. I put some extra comments in just to make clear. Oh, and again, by the way, on the function, again, after each of the differential equations, you want to probably put a semicolon, again, so you don't get too much output. Put semicolons in all of the places where you might actually have calculations or something showing. But let me show you this on paper. I'm going to print this code out right from Matlab. And so here's the whole code as I typed it into Matlab. Pretty much everything the same as I had on paper. As I said, I mentioned, put semicolons in here and up here and did everything like that. So let's go ahead and run this and see what happens. Again, be sure you're up in the editor, then push the green arrow and push run. And then see what you get. And there are curves. This gives you the output for the 3 dependent variables. It plotted real nicely. And so now we can add some other features to this just to make things look a little bit nicer. Let's go ahead and do that, but that's the output we were looking for. Now I'm going to do several things here to make the plot look a little bit nicer. I'm going to label some of the axes along what's normally the x-axis. That's going to be the t-axis. So I'm going to label it this way with quote marks t-axis. Then the y-axis I'm going to label as x, y, and z because those are the values of x, y, and z. And I'm going to change the font size of like all the numbers on our graph, and you can do that by doing ax equals gca ax dot font. So I'm gonna make it the size 14, and font weight is going to be bold. So I'm going to type all those in. I typed those things in after the last plot command. Now, there are other places we could put this, but I'm going to just give you one place to put it. I typed these in after the last plot command. Here, I put in the X label, the Y label, that AX equal GCA, etc. But be sure to put it in before you get to the function. This has to be before you get to the function. So put those in, and then let's go ahead and run it and see what we end up getting. And so we get this. Notice that the coordinates are all in bold and they're larger. Then we have T marked on the horizontal axis, X, Y, Z on the vertical axis, just the way we had hoped. One thing else I'm going to do to make the plot look a little bit nicer, I'm going to make the curves thicker. I'm going to the plot, each of the plot commands for the 3, for the X, Y, and Z, I'm going to change the line width to 3. That's a thick line. Again, put in quotation line width, then comma 3 on each one. And I'm also going to change the colors of each one, sort of force the line to be a certain color. Now, right after this, I have a comma, quote, a dash K, we'll make a black line. In quotes, a dash dash B will make a dotted blue line, and dash R will be a red line. So this would be like for your X will be black, Y will be dotted or dashed blue, and Z will be red. And so once again, you see here, I've added those to each of the plot commands. I have comma in quotes dash K in quotes lined with 3 dash dash B dash R. And when we run that, we get this. And notice the lines are thicker now. And the, would we say the Y variable is the dashed blue, the X was the black, and the Z is the red. Nothing we can do is label those colors. So we made every variable different color, but we might forget what we had named each one. So we can put a legend. And so it's real easy in Matlab to put the legend. So for your plots, whatever your, you can mark here, this will be whatever your first variable is, whatever your, say your W1 is. This would be W2, W3. So I just named this X variable, Y variable, and Z variable. So let's put that in and see what happens. So once again, I just put the legend down here. Again, just be sure it's before your function, because remember your function is like a subroutine. You don't want to put anything that into the subroutine supposed to in your main program. So type in your legend here, and let's run it again, see what happens. And so now notice that the legend came up here in the upper right, and it shows us the solid black line is the X variable. The blue dotted line is the Y variable, and the red line is the Z variable. So you have all of your plots identified. And there you have it. That's doing a system of ordinary differential equations using a solver in Matlab. Again, I use the solver ODE 45. There are many solvers you can use, and they're all set up the same way.